Hello. Where's the mouse? Here. It's a cinnamon moon. What's moon in English? And nuts. What band? I don't know. It's a random copyright-free rock playlist. Wouldn't really call this rock. But okay. Yeah, but what is the English name for moon? Yeah, I like metalcore. But it's called Abandoned by a War Within. It's pretty nice. Oh. Thank you. What you drinking? Latte macchiato. Hi Hugo. Nussschnecke, Mondschnecke. Zimtschnecke. Time to get fat. So there's definitely a chance for a copyright strike here, but whatever. Music is louder than me. That's not true. Music is minus 20 dB. I'm minus 5, but I can make it quieter. Is that better? Nothing wrong. I want to learn to design this stuff. And it's a good opportunity. It will look prettier, but it will be more expensive and weaker. It's more like a learning thing. This is the gimbal. The laser cut version. This is a lot. Yep. Even bigger motors. You don't need bigger motors. Or what do you have in mind, Diamond Bugs? Audio level fluctuates a bunch whenever you talk or go silent. I don't know, maybe while you're watching Twitch. I don't have anything going on regarding that. No filters on the music. Maybe you're here. No, the limiter shouldn't. Now the limiter is in effect. Check my wavelength. No, it looks fine on my side. Wait, Ultimate Designer we don't need. Save it all.
I've come to recognize that despite these harrowing circumstances, there's more history yet to be scribed. I've reinforced the big breath in my lungs, and I will not let my stubbornness drag me into retrogradation.
Let's clean up a little bit here. Not leaking anything.
This time, I refuse to grasp a
Which
deeper
plane?
understanding.
What do you
of
like?
who I was and where I have to go next.
More modern stuff, old stuff? I'm not an expert.
I've so many reasons to tell the tales of time to come.
What is the sticky mouse? Modern jet? F16, F18 are nice.
Let me think it's all good. What you did was unforgivable. Lying to my damn face, got you feeling cynical. I was at the pinnacle, what was going wrong? Fucking knew it all along. Let me think it's all good.
No,
It was crazy how time flew.
I'm an electrical engineer.
But now, baby, look at you. This is all
No.
because of you.
I have to wash my hands. Be right back.
Straight shot to your face drop. Put the brakes, but I can't stop. You wanna sound like a mascot. Was all I gave to you, got caught. And now I'm feeling like a free man. Show me fishing like a seaman. She looking at it like a pecan. Cause it's always in season. Yeah. You burn all the bridges you rode. I gave you my heart and it broke. I took it all back, but I'm gone. Yeah. They dropped in the city explorer. She's out in the whip and it's foreign.
Okay. Wait, I need chat. Caps. Why do I have to always like reauthorize caps when it's free anyways? It would be nice to be able to use the higher gear ratio on smaller motors. But, these hovercraft, hoverboard motors are pretty epic in terms of size to performance. So. Okay, there's chat. Does it also work? No. Cool. Oh no, it's just delayed. There we go. Yeah. Okay, so who guesses what this could be? This new coffee machine is really good. That's pretty much what the active pedal's using. Oh. Just maybe we'll design one for the fun of it. What is this? This is a motor and a linear actuator, nothing else.
What you think
what to think about when you're born into a fire. Let them burn it out.
Well, that's the principle of the active pedal. Like there's the motor connected to this thing here. I mean, this is not connected right now, but you would connect it. And then there are threads on this. Can I actually add threads here? Put a thread on the outside of something with this tool? I have no idea. Probably not, huh? Outside thread? At internal or external thread to cylindrical geometry. Step file, but yeah, there's a thread on there, and when you turn this will move the slider here. And then on the Suzuki pedals, there's the pedal arm here, connected to this with that load cell. Yeah, I've seen that. But yeah, we're not here for that. We're here for this. It's the current state. So this is how the gimbal works. See, this is these are the how you call these, the pulleys. And then you can also, like, it's a bit sketchy when you're trying to grab it here. Kinda have to do it here. Yeah, I mean the haptics and the force feedback pedal is completely different. It's my great temporary housing. How's the backlash on the gears? What gears are you talking about? We do need to replace these pulleys. Oh, yeah. This, wait, where's my OBS? This is, see, this thing connects via belt to the motor that would sit here. And then it turns. If the motor turns, the joystick turns.
It's cool, just lying here on the floor. Cold tiles, my feet against the door.
But we do have to figure out which of these joints is the correct one here. And then change the housing, temporary housing. There's not that much left to do here, actually. I mean, this is the gimbal arm. I reinforced it quite a bit here and here, because like the simulation for stress at 35 Newton meter showed some deflection at the 10 millimeter, and this is fine now. But yeah, here I still have a, I think 16 millimeter. Yeah, but I did. First of all, we can this common parts parametric pulley. Save as parametric or CNC. Okay, and here we will actually this. This. enter. Just have to redo this part here. Can I quickly actually... What if I insert this here? Then we will... Still learning. Is this a component? Is this... Ah, it's grounded. On ground. And if we join this to this. Flip. I think if I now create a sketch on here. Why can I not go into the 3D view? And here, hide this. Project these two. What happens? Can I? What happens if I now delete this? No, these are not defined. Oh. Just 17. 10. Yeah, for using this time. I love metal, yes. Is there an elegant way to replicate this onto this site? I mean, I heard you're not supposed to use mirrors in sketches, so I don't know. Maybe we'll just do it like this. Okay. This here. Do I need threads in here? I don't think so, right? Threads are here and here. Yeah, that should work. No, doesn't ring a bell. This is what? 5mm, so that's an M6 hole. M6. Okay, now we can... Wait, like what hole size should I use here? Not 6 or M6. Pass through. Wait, first of all, we actually will do this. Not extruded, but as a whole. No. Hello? Why is this as? I want countersunk. What I like? Why do I have to input this value here? M6 countersunk through dimensions. Why doesn't he know stuff like this? What? Wait, 90 degree. Shouldn't he automatically? Like I always have to like, do you do it like this? The 13.44? I'm just surprised that you have to do this like manually. Okay, but we actually want the 60. Okay. The music already so quiet. I can make it quieter. Okay, that's 60 now. Save. Will it automatically remove all the joints if I remove the components? I don't know. I mean, I can remove it basically completely. Okay, so this will make the whole thing wider, which will make this 4 millimeters, I think. That's perfect? Okay. 20. Oh. Ah, the bore is parametric here. Okay, let's actually try to remove them. Delete. Yes. Yes. Delete. Yes. Housing we will quickly unground. Put away. Then we'll have to add the new pulleys. Common parts for CNC. Insert. And this goes on here. Yeah, it's a smiley now. Wait, this was rigid, yeah. And another one. And this one goes on here. Flip. Okay, there we go. I can maybe make some music that is a bit more chill. Epidemic sound. Music. What do we want? Funk. Okay, this was 20 now. Yeah. Then we can make the housing temporary one a bit bigger. Oops. +4. And here as well. Oops. Save. Ground to parent. Ah. Oh, yeah. Okay, and now we should be able to join the joystick back on. Joints in Fusion are so strange. Okay. -10 and +10. Will that do the job? That is 10 degrees. No way, this is 10 degrees. Yeah, but this does not look like 10 degrees to one side. Look at this. It's more like 30 or so. What is... Don't really understand what's going on here, to be honest. But whatever, it doesn't matter. Let's join the other one here. Hopefully without any conflict. Revolute. Looks good. Now I need to figure out how I mount the whole unit. Like the original has these screws sticking out, but I kind of want to do it the other way around. Have like shoulder bolts that go in here. Will probably be a slight pain in the ass to mount. But I don't know. You don't get play-free operation if you use screws into a bearing. When I'm designing an assembly like this, I like to constrain my parts to reference geometry. I have no idea what that means, to be honest. Like, I don't even know if you can do it in here. Contact set. How do I add to... Like if you do all contacts, it will... Do I have to select the parts first? New Okay, so this and this. X and Y axis, so the holes in the hole. Yeah, but where do I get those axes from then? Something broke here. Oh my god, this is so resource intensive. Yeah, joints in Fusion are a giant pain in the ass, if you ask me. Like the assembly in Inventor or SolidWorks is much nicer. What I don't like about SolidWorks is it's even slower than Fusion. And this is not a slow PC by any means. Just do it. That's my suggestion. Tons of tutorials. Just follow them. Look at other designs. How? Ah, because we never mind. I just do not show the other part, but we still have the joints in progress. Broke it? Nah. Works just fine. What was that? Kingman, thanks for the raid. Appreciate it. Thank you, thank you. I have the thing in SolidWorks as well, but I'm still not really sure which software works the best for me. Onshape also is very nice. The one thing I don't like with SolidWorks is if I should ever maybe design something and choose to sell it. SolidWorks is like insanely expensive for the commercial license. Fusion and Onshape is, I don't want to say cheap, but yeah, this is an older version of the same thing in SolidWorks. I also printed some parts here earlier. I think the walls here are maybe a bit thin. How thick is this? Wait, I have the thing here. 3.9 millimeters. Probably have to beef that up a bit. Questions for any mechanical engineers here, or just people that know stuff. Are there like thick spacers? I want to use shoulder screws for this. So we need 20 plus 5, 25 plus wall thickness. So 30 millimeters shoulder bolts. And obviously I can't use nuts for that. Why? I don't need an H pattern shifter. Shoulder screws. 30 millimeters. 8. Yes, this one here, please. So, where would I join this? Probably into here, right? Join this. Man, joints on Fusion are such a giant pain in the ass. Into this. Wait, this is an M8 hole. Need to change that to an M6 hole. But obviously this will not work here. Also, this is interesting. Isn't it... How thick is the nut? Also, this is rigid. I mean, this should be 30 now. Yes. So this must be 6.5. With on cell? I've never heard that word, so I guess no. Okay, so the idea is there will be a bearing in here. Uh, 608 or something like that. A 608 is 7mm in width, right? How can I replace this by like a spacer or something? Does something like that exist? Basically, I want a washer spacer that is 5mm thick. That's fusion here. I'd screw a flange mount bearing to your plate and have spacers on the inside. Yeah, but how are these spacers called? Like the idea is to have like the bearing inside the housing, and then you can go through it with a screw into this, but I need like a little spacer thing here. 5mm space. Okay, it's just called spacer. So for an 8mm shoulder screw, I need something bigger than 8mm. Like 8.1, 8.4. I guess this is what I want then, huh? What's the outer diameter? 16. Yep, that will be CNC'd. Delete, delete. Probably lost the movement now, huh? But that's fine. I need some clearance between the wall and this. I mean, it could also be like 1 millimeter. Or like 3 millimeter. We could, I think, yeah, I think we should. Yeah, actually, it makes no sense. If we add a bearing here, wait, do I have it in common parts? The 608, 688. I don't. 608 bearing. Flanged. Do I want flanged? Why does it ground this thing? Yeah, I think 7 millimeter walls. Oh, would that be expensive to make though? 7 millimeter aluminum housing? But that probably would be the best solution to mount this. Have the 608 in the housing. Like, what is this? 16? 22. Hmm. Oh. I'm just thinking about the smartest way to mount this in the end. I guess with the flange outside would probably be the best. I'll show you what I mean. .608 flanged. They are 9 millimeter 608. Download. And basically join this. Doesn't really make any sense right now because it's wrong size, but just to get an idea. And then we would just have to fill this gap, which will be like what, 3.5 or so? 2.5? 3. Okay. Yeah, that actually might be the best. best approach. Also kind of looks nice. Yeah, that's what I'm thinking as well. Like here I'm working with these little, oh god, can you see them? So to eliminate DIN 988 shim tolerances, and I guess here with the flex I can just like bolt that through. Like if there's like slight off tolerance, the housing will just bend. Yeah, I think that's actually the best. And then use regular washers. The fuck is number 10 screw size? I'm 8 washers. One millimeter. Three of these. Do we bring it closer to like even maybe 1 millimeter? Do we need... No, I think we'll leave it at the 3 for now. I don't really want to go any custom size here, because like in the end, if you don't want to 3D print this part, 20 is something you can buy. 22 is not something you'll be able to buy. Yeah, the software is free for non-commercial use. Oops. Huh? What did I do wrong this time? Join this onto this. Flip. Join this onto this. Flip. Rigid. join this here. Conflict F. I need to update the walls, obviously. But yeah, that's the idea. I think that should work, huh? How do I measure the position from this to this? Wait, I need actually the position from the center hole to the end of the screw. I think. And then? Is this even symmetric here? 107.5. 87.5. 10, and this is 12. But from here to here. Minus 30 and 27. 27 minus something. So 107.5 plus the length divided by 2 plus the length of the screw. 107.5, and that was, what did I use there? I think 30. Minus 3. 80.75. Yeah, but the shoulder bolts are always like 11mm thread after that. At least the ones that are buyable. Like if I look here, shoulder screw bearing is what, 7? You probably cannot get 7mm, so I do. But then we need the thread to be. It's also like 11 is the longest. Doesn't hurt like that. I mean, yeah, it doesn't make that much sense, but eh. Just get a cheap M8 with a short shoulder. Like, let alone finding an M8 with an 8mm shoulder already is difficult. Like, there are these same size things in this, but it's actually hard to buy them. Like here, the same size. I mean, what's wrong with this? It should work just fine, no? Into machining? What do you mean with machining? Ah, I don't have the space for that. I don't even have proper space for this. Okay, in theory, this... Maybe that works now? We now join this. Freaking bearing disappeared. No, it doesn't look right actually. I heard the name, but don't know what that is in detail. Oh my god, I can't believe that this is the biggest challenge to get the freaking hole in the housing right. Like my brain can't compute this right now. I think we need to add another... Or I just use this. I mean, also it's an M6. This one is an M6. I don't want to do any manual, like, machining. This is 8mm and then into M6. I still don't know how I can properly measure from the distance from the center of this screw to this. I guess I have to put this somehow like into a 90 like upright, but I don't even know how to do that, to be honest. Wait, this is one of the revolutes. Angle. I should probably start the assembly from scratch. Yeah, but there must be a way to measure it, no? Yes, for the power. How much flex resistance? I do not understand that question. This can't be, like, why can't I take the center of this? I don't want to know, like... Okay. So 73.75. Or till here 77.25. That cannot be right. That will be way too small, I think. Does that make sense what I'm doing here? Probably not. $77.25. guess it makes sense. Let's see. Learning is hard if you've never done this stuff in your life. I'm probably missing some very basic concepts, but always felt like just like the best way to learn is by just trying. So the question is, will this... Wait, first of all, this is not a revolute. This is a rigid joint. And now, in theory, this should not give me a conflict anymore. Okay. So what would be the best way to connect these profiles? I mean, 5mm wall. Have something on the inside, little blocks. Like going through here with like, what, M3? I kind of want to avoid that. Oh god. Next thing is I need to figure out how to limit the motion. I mean, it will bolt to a plate from the bottom, it will bolt to something from the top. Let's quickly like grab the FFBeast. Upload. Right. Where is that stuff? Just for reference. Enclosure. This one here. Yeah. Let's just quickly see the price difference between 5mm and 7mm on the housing. I'm just gonna take this as a reference here. Export. Let's put it on downloads. 5mm panel. Export 7mm panel. Upload models, downloads. Yeah, sheet metal is what the original design is doing. Okay, 5mm panel is $18. Oh, $2. It's like nothing. Why do they even care about that? This is insanely cheap in general. Even the higher grade aluminum, which is probably not necessary at all. Anodized black, $24. Very stiff corner fixing, but do I really need that in this case? Because I mean, this whole thing will get something on top and on the bottom as well, where we can screw it in. But I guess if it was 7mm, we could use like M4 countersunk screws. I don't know. I mean, of course, you can just use these on the inside as well. Just kind of like, I don't know, I hate aluminum profiles. Yeah, it will be insanely rigid. I don't know if it's really necessary to like reinforce it somehow. I mean, like, could maybe do like a little, like a cube in the middle where you bolt through instead of through the walls, but is that really necessary? I mean, probably not. I still like, I can't get like $24. That's insane. We should design a sim racing dashboard. Probably get this manufactured for insanely cheap here as well. Okay. No, it's a one-axis part, no, two-axis part. But still, I mean, like, even this here is, I think, $60 or so. Gimbal arm. $50. We need two, so like what, 95-ish? 88. And if we do economic, $82 for two of them. I think that's actually cheap. We don't really need any finish here. I would probably still get like anodized in pink. Why would you want the sides to be CNC'd? What would you recommend? It looks good and it's cheap to get a good finish on. That was my idea behind it. Like, I mean, yeah, laser cutting is significantly cheaper, but... You know, instead of spending an hour to sand everything smooth, to have nice corners and everything, I like to spend weeks to design something, learn a new software, order it for more money. Makes sense, huh? Yeah, it will. I mean, for example, this here is from JLC. I think it actually... This is just like, holy overexposure. This is Beat Blasted 120 things, I think. This is the mounting adapter for VKB. And yeah. Okay, so what else needs to be done on this? Did I save anything here? No, don't save. I mean, obviously the motors will have to be placed. We do want to make... I wonder if I can mount one motor on the inside and only have one on the outside. There's some space on the inside, but the motors are also gigantic. Here. It's kinda big. That's what she said. Well, it could work, actually. Yeah, and you need two of those. I mean, in theory, we could make a little fancier version of this housing. I mean, in the end, it's just like... Do I have a... Yeah, here. Would be cool to have something where you can see what's going on the inside. It's just magnets. A little... little ring with a bearing mount and magnets. And then inside you have that... the motor thingy. So I think would be able to shave off a little... not much though. Maybe a centimeter or so. Yeah, right? Actually, it's not super strong. Okay, don't put it together because like it's really, really hard to get this out once it's in there. Where did I put my my dingens? Hier. Berechnung der Riemenlänge und des Achsabstands. So we are using a 5mm. We have 60, 20. Well, actually I need... maybe this, roughly. Now the big challenge again, how to measure the distance. Not like this. This is probably as compact as it, as it can get. Ish. Okay, I also want to mount this directly. And then use some sort of belt tensioning system on one side. I need to think about how I can access it so I can put some tension on the belt then. But just roughly. $50. Hey Jochen. I don't know how to measure. Do a completely noob approach here. Ah, perfect. That's how it's done in the original design. It's like elongated holes for the mounting of the motor, and then you basically push it down, screw it in, done. But I would just like to use a belt tensioning system. But honestly, how on earth do I measure the distance between this? Oh, for fuck's sake. No, not this. The center of this and the center of this. I just don't know how to do that. 81, but with the thing. But I guess 80. Could work. What is the diameter of this? I don't even know if this model is correct. 130. Yeah, then 80. What is the outside of the bearing? Like 22? No, 25. $25. 25 plus 130, 155 divided by 270, 80 should work. So if I say Achsabstand 80, let's see if we can fit a hole. Oh, great. I think. I'm just like, obviously have to make the housing proper from scratch. Just testing stuff a little bit. Okay, joystick assembly. Can I? Oh, this will probably completely break when I try to make the 20T pulley here. I'm very proud of my parametric pulley. Yeah, like I said, the holes probably don't work here. Bore needs to be 16. Yeah. Anyways. Okay, and now we will fit... Oh, will that work? Can I join this onto this? I can. Okay, here we see the problem with inside mounting. This thing is just so big. See, there's not enough clearance here. I would have to do it like here or so, and then the joystick is... Okay, so I think inside mounting is definitely not an option, not even for one of the motors. Will have to be here. Let's offset this just by 1 millimeter. So we don't get the artifact thing. And then obviously it's not the whole motor that will spin, but only the inside part. But I didn't model the motor completely. Oh, they don't get terribly hot. Yeah, I guess it's fine. I guess it's fine. Maybe, like, if I ever feel like doing insanely unnecessary stuff, I'll do a housing as well. Just glue in the magnets. Could you cut a outer case? Could you cut a outer case? What do you mean with outer case? I mean, what we could probably do, just for the looks, is make our own this here. Just in pretty. Wait, where's the Schieblehre? There's the Schieblehre. What is the diameter here? 125. Let's actually see, just for science, how much it would cost to make something like that. So 125 millimeters. Thickness is 7.5. So 110. What do we need here? I don't think there's much material to save. No, I'll just get that from JLC. Have that be manufactured in China. It's insanely cheap. I don't know how they can make money of that. So we'd need 10 millimeters for the bearing. And then this. So here we want 10. But into the other direction. Hey Kuzo. Oh, we are just playing around. And then this we want. This here is 12, but we don't need 12. 38. 38 from the... So, 48. No, minus 48. Now we have 38 here, right? What? 38, yeah. And what bearings are these? 6202 RS. Okay, so 6202. Do you ever give feedback on the design to the manufacturers? Of what? You mean like with reviews? All the time. When I do a review, the ideal result is the manufacturer takes that suggestion and improves their product. And I would say like about 20% of the manufacturers don't give a shit and just don't answer. 40% appreciate the feedback and improve their product, and 40% are mad at me at making suggestions. Roughly. Um, 11 for a shaft diameter of 15. Can we find something that is maybe 10? Ideally flanged. So we want a 15 in 15 diameter. Bearing. Where are bearings? Shaft diameter 15. Width. I want flanged. From 11 to 7. Lasering acrylic. I do not know that. But you can also check PCB Way. It's like JLC, a bit more expensive, higher quality, and they offer... Oh, they offer everything. Like for CNC, you can look at these materials here. Rubber? What the fuck? Carbon fiber. Oh, carbon fiber. The math tells me, yeah. Yeah. No comment. Oh, retaining ring? The fuck is retaining ring? Interesting. There is surprisingly a lot of a high amount of manufacturers that will just hate you for making a suggestion how to improve the product and never talk to you again. I'm not giving you any names, but it's a thing. That's all I can say. I don't know if you missed my question. Maybe I did. Let me see. What's the size of the outer faceplates? You mean like basically having a housing around the motors as well? No, actually no. For example, CNC or PCBs, you do not get better quality outside of China. I think it would just be too big. I mean, the motors are not really annoying. It just doesn't look as nice. Should that really be something where you pay attention to? Probably not, but yeah. What was 6202? Let's just insert one here. Step, download. Can I move it? Okay. 35. Okay, so we want whatever. 35 and then 11 deep, right? Yes. Actually, let's make it through hole. Then there should be at least 30 millimeters here. Yeah, 38. Let's make it a little bit pretty-ish. Mounting holes on the inside here. Bearing. Oh, but do we actually gain anything from that? Apart from that, it might look nice. 50.7. Don't worry too much about mounting. If you want to do streaming, then just stream. Hey, we gained 0.8 millimeters. About what then? But why? Okay, just in theory, how much would it cost to have, like, Untitled is a good name, to have a pretty looking motor housing? Yeah, it's like pray to the tolerance gods that it might fit. I'm just like curious about a rough estimation of price. $62. Not good, not terrible, I'd say. And we could add like black anodized, laser marking something, 66, then we would need 2. 120, economic, 113. Something to think about. Okay, don't save. Great housing. I'll just order it like this. Just curious, how expensive would this be? Because there would be a lot of material wasted for this. Don't do matte. Have you tried it? Does it not look good? I have the sandblast stuff and that looks pretty nice. I guess a lot of material. Yep. This is not suitable because like it would be a giant block of aluminum, and then they would have to cut away all the stuff in the middle. I still need a mic for the rig. Just get a headset. It sounds better. To beat blasting and black anodized glossy. Oh, this is like CNC aluminum. It doesn't make any sense to do a design like this. Don't get me wrong. I was just curious. Well, 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 well. What did I have here? 130. Is that accurate? It's probably not accurate. 134. It's actually 134 because it has this. The motors have this protruding edge here for the tire. So what's the gap between those? 2.6. Perfect. We have 0.6 millimeters of clearance. I have no idea how to model a frickin' belt. Can I do that in Fusion? Like, so that it also turns? Or not, huh? Exactly. Can get subber cut. What? Yeah, but can I model it so that it, like, you know, like if I do this, that the belt would move? Not super important. But how thick is a belt like this? 4 millimeters from here to the top. Two millimeters roughly from the top of this. Yeah, definitely enough space here. Like, I mean, oh yeah, easy, easy. This I can easily 3D print, the big one. These, if you buy these pulleys, they are actually not that cheap. Like it's like 25 euros or so for the big one. Whereas you can easily print them here. That's what I use in the Beast. Just because it's a bit more precise than the... Can you focus? No? Like, don't print the small one, but the big one you can print. No problem. Definitely more precise than me drilling holes. Yes, I wanna mount something. I just have to think about it. How to do that. So here will be the 20T pulley, and then ideally something that pushes against... Or would I have something in the middle that pushes? No. Probably better to have something with a flat surface that pushes the belt towards the middle, for example. Like in the original FFBeast design, it's done by elongated holes for the motor mount, where you basically just push the motor down and then mount it. Let's do a nice render. But on the PC, this will take forever. Interestingly, the rendering is like 2000 times faster on the Mac. I don't know why. Why? Trying to understand why that would happen. We need to add where is that here? One here. And another one. Flip, rigid. Nope. Yup. Two stepper motors. These are BLDC motors. One here, one here. No. But isn't that how it's done in... I don't understand why that would have any impact, to be honest with you. Oh. And we'll definitely have to get the center part in purple. Yes. Well, to be honest, I do not know what pink is in the JLC world. If it is this purple, couldn't really find any good samples. But yeah. Really? Is OBS struggling with the encoding? Yeah, but I mean, this is lagging for me as well. But is the webcam lagging, for example, now? Or just the screen capture? Cam 2? Interesting. Yeah, it's probably the GPU that is. Is this taxing on the GPU or what is? Why do you not like purple? CPU. Interesting. Didn't expect the CPU to get hit by that. Eh? Eh? Yeah, that's a very good question. Can you set that up somewhere? Yeah, this is a 7950X CPU. One Direction. Oh, I see. I see. Because obviously if I put tension on here, it will not affect this side because there the belt is sitting in the grooves, right? This is a Warthog joystick. The A10C, I think. Just a replica. In the end, all the joysticks are nearly the same. Like some have some different heads here, but very similar principle on all of them. Okay. It's actually very interesting to see the movement of the gimbal part in the middle here, if you turn this to the extremes. See, it's not straight in the thing. Dude, joints are horrible though on Autodesk. It's much better in SolidWorks. I do have the F18 stick here, yeah. What I learned today though is parametric design. See? 60 teeth pulley. And if I go here, I can make this a 120 teeth pulley. Takes 2000 years. Or not. In Inventor, it's also not great compared to SolidWorks. Now it's a 50 pulley. It's pretty cool. Just takes forever to compute. Here, look how laggy it is. I actually do have Inventor on here. Pretty cool. Yeah, I mean, honestly, in the end, it's here. This is you install the software, and this is how it starts. Great. But yeah, I made the joystick in SolidWorks, in Fusion, and in Inventor. When did you set the number of teeth in the design? I mean, like from the beginning, I'm working with it. Like outer diameter is calculated from the teeth. Inner diameter is calculated from the teeth, and this here, the circular pattern. Yeah, pretty much everything. Hello back, I'm Dan. Badumts. But yeah. DIY active pedal? Who's up for that? Yeah, I'm using the printed poly. It fits very, very well. Where did I put the belt? Here. Focus. Come on, there's no face anymore. You can focus on this. Where's the belt from? From AliExpress. It's an HTD 5M 425. Oh my god. 425 is the belt length. 5M is the spacing between the things. Active pedal with hover. Oh, you don't need a very strong motor for active pedals. Like a 1 Newton meter motor is good enough. Because it uses this linear rail. Which has like an insane gear ratio. Yeah, you don't need any power in the motor pretty much. Inventory. So you will hate your life. Have fun. I'm also done for today anyways. Yeah. But yeah, now just have to make like a housing that doesn't look like shit, and then I'll order a test run. Then it will be super fancy and unnecessarily expensive. Oh well. Here. I mean, it's very easy. Create mirror. Bodies. Component. Mirror plane. Fuck. Done. Oh. Okay. Bam. Housing done. Oh shit. Wait. Join this. Fuck, I hate joints in Fusion. Done. Housing done. I'm just kidding. Yes. No, like housing I need to do, like also the electronics need to be mounted inside, then the encoders and everything. We'll continue with the project another day, but now I need to go and make food. Food is good. Save. Face. Alright. Thanks everyone for watching. I'll stream on Wednesday next. Tomorrow is like 2000 degrees, so I don't feel like doing anything. So yeah, thanks for watching.